have to find. So in this question 148 sort list, we are given head of a linked list and we have to return the list after sorting it in ascending order. So we're just given a single linked list and we have to sort it and return it, and also we have to do that in O n log n time and O n space. Okay, so let's think about how we would come up with the solution if we didn't have this follow-up condition, right? Like how do we solve this if we don't have the like memory constraint and the space constraint? So what we can do is we can have a like auxiliary array of size which is equal to size of the linked list, or just simply right, and we'll insert all the elements of the linked list, or basically all the values of the linked list in that array. We will sort the array, then this will be our like first go, and in the second go we'll just copy the element from the array to the linked list, and yeah, that would be it. But that would be shallow copying. By shallow copying, what I mean is, so let's say my linked list had value 4 2 1 3, right? I make a dummy vector, and the that vector will contain 1 2 3 and 4. Now I do next is I copy the elements from the dummy vector to the linked list. So I just put 1 instead of 2 or 4, 2 instead of like 2, so and 3 instead of 1, and 4 instead of 3, right? So in this case, let's say the address was A1, the address was A2 was A3 and A4. Here also the address would be same, A1, A2, A3, and A4. So I'm just copying the values, and the linked list, that is still the same, and that should not be the case. I want to just return the like in future it might be the case that I am using the address of these nodes. I'm using this particular nodes. So and I don't want to change their value. Basically I want to change the position of the node. So copying it this way is not that that's not a good solution, because in future I might need the node and I have a particular value associated with the node which I do not want to change, and I'm changing the particular value in this case, right? A1 was associated with 4, now A1 is associated with 1. It should not be the case. So what I want to do instead is I want to put this A3 first, right? So the next of A3 will change. Now A2 will come. Now I want A3, A4, and then A3. So I want my setup to look like this instead of what I had. So how do I solve that? Uh, so what I can do is I can have a map, like maybe I can have a map of like, oh sorry, so I can have an unordered map with integer and pointer to Leetcode, and let's just say MP. Okay, so the values of this list are not unique, right? So I'll get in trouble in that. Or maybe not, yeah? Will I be in trouble? I don't know. Uh, so what I want is just sort the elements. Well, let's use ordered map. Yeah, this makes sense. Now I will just iterate over this map. First, it will give me like now the entries are in sorted order, and my key is integer, so they are in sorted order of the value of integer, right? So the first value would be MP like 1, and that is equals to A1, right? So what I do is I set so what I need to do is I just need to set the next of the first to the next iteration. So I'll store this somewhere, right? I'll store this as previous, right? And I'll set previous next as current, right? Okay, let's just do this like this. Auto it, and I'm iterating over the entire thing. And my current is just 8.2, right? And my previous next is current, and my previous will become my new current. This makes sense, right? So I need to assign some initial value for current. So let's say my initial value of current is null maybe, and I'll have some value for previous, right? So if I do this, let's just try run this. So I have this thing in map, and I want to so I'll first fill the map, and just list node current is equals to null and previous. Okay, I'm iterating over the map. So current is at second, which is the the value, which is this node, pointed to this node, and I'm setting previous next as current. So initially I don't have any previous, right? I don't have any previous, so that's also something I have to take care. So what I do is I'll just set this as some unknown. So let's set previous as this list node temp. Yeah, let's just set this as list node temp. So in the first iteration, my current will be A1, sorry, it will be A3, right? Previous will be this temp, and next to it's just temporary node which will delete in the end. Previous next, that's this temp next is pointing to current. Okay, fine. And previous is equals to my current, which is current becomes A3, right? Previous is A3 now. So previous current, initially it's nothing, right? It's just null. And my current, that is temp current null. In the second iteration, my previous becomes A3. My current, that becomes my 2. What is this? Is A2. And I do this previous next as current. F4, sorry. Right. So let's just solve this way. So this seems to run fine. So let's run this here. Alright. So first let's fill the map. Like this should not be combined. This has to be something related to sort list. So let's copy this and let's just refresh this thing. Yeah, let's refresh this. Okay. So this will be another map and list node mp. Now I just fill the map. So I just do that by iterating over the list. So I use this temporary variable which is initially pointing to my starting of the list, which is my head, and I iterate over the list till this variable becomes null. So I just put temp val as temp and just move forward. Next, so this will fill up my map. Just copy. Okay, wait. So I'll just copy this part and yeah, I'll just delete entire this thing. Okay. So this seems to be fine. Yeah. So this was my code. So I have this card as null. Temp is new node. It's just a dummy variable. So I'm using any. You can use any other value. It would work fine. Now previous is equals to temp. Fine. Previous. So what the reason why I set this temp, I created this temp is because I wanted to use previous dot next. So I need to hit previous to point to some address of a linked list of a list node. So I created this new variable. I'll just iterate and this map mp would be sorted because we're using an ordered map. Like, no, this should be ordered. Okay, yeah, seems fine. So I'm using temp in two places. That should not be the case. So mtp, why not? P card next. Oh yeah, let's run this. Pointer to list node. Okay, this should be a pointer. Yeah, works fine. Let's try this for an empty list. Nice. So it crashes here. So I need to have a null check. Just return that. And this should work now. Now let's try for one single input. One. Yeah, let's submit this. Oh, nice. So it does not work for this. And what's the issue here? So input was 5. So 5 is coming 2 times in the input. And okay, because we used a map. Oh, nice. So map, in case of duplicate values, maps does not like have multiple entries. Like the key thing here, that is unique. So if we have two values, let's say 5 and a4, 5 and a7, then it will only have 5 and a7. It will override the first value of 5 with the value it sees the last. So we'll need to use a multi-map, and to use a multi-map we'll need to see some specs. It's similar to map, that is in the same case, and that's the only thing we want. We want like multiple elements to have same keys. So let's just do this multi-map and see whether this works now or not. This won't work. Okay. So the way we insert in multi-map is by using this insert thing. So let's have this. Okay, there. And now let's see. Okay, works for this. Whether this works for this or not, should work. Nice, it works. So let's submit this. Should get accepted this time. Nice, it gets accepted, but as we can see, it is faster than only 11% of the C++ submissions, which is it is fairly slow. And the reason for that is we're using multi-map here, right? So what we want to do is we want to on this follow-up condition as well. Initially, we like okay, let's just have a look at the space complexity. So we are creating this multi-map which is containing each entry of this multi-map is containing an integer and a point and a like address to integer. So that's and the size of this would be equal to the number of entries in the linked list. So it is taking on space, right? And the time complexity would be just forming this multi-map that would take n log n time, and just having this one iteration over there over the multi-map. So that would also be like n log n. So this would take on log n time, and this condition of over memory that's not being honored, although the time complexity is less